Welcome to this video on Intro to Graphing Quadratic Functions. By the end of this video, you should be able to sketch and describe the properties of a quadratic graph. So we're going to start out today, and we're going to try a couple of these. We're going to be relying on Desmos very heavily, so make sure you've got Desmos pulled up and you're ready to use it. So the graph of a quadratic equation is a U-shaped curve called a parabola. And for Algebra 1, it's either going to open up or it's going to open down like this. So using your graphing calculator if you have one, or go to Desmos, go ahead and put these equations in and sketch them on here in the approximate location and answer these two questions and come back once you've done that. So once you put these two equations into Desmos, x squared plus 2x plus 5 looks like this on the graph, and negative x squared plus 2x plus 5 looks like this graph. Now if you notice the equations, the only difference between them is this negative sign right here. It's not in this one, but everything else is exactly the same. So what way does your parabola open when the a value is positive? So when there's no negative sign in front, our parabola opened up like this, so it's going to open up. What does your parabola, how does your parabola open if the a value is negative? So here's our negative a value, and our parabola will open down. Okay, so whenever you see a negative sign out front like this, that means your graph's going to open down. No negative sign, it's going to open up. All right, there's a couple interesting things that we've got. We've got something called an axis of symmetry. It is the imaginary vertical line that divides a parabola into two equal halves. So where the parabola turns direction, there's a vertical line that goes right through that spot. This is called the axis of symmetry. Okay, and the way to think about the axis of symmetry is, do you remember when you were in kindergarten and you would fold the paper in half and you would paint like half the butterfly, and then you would fold the paper over on top of that to make it duplicate it over on the other side? This line that you folded on, that's your axis of symmetry. It's what cuts your parabola in half, and it's perfectly symmetrical going out in both directions from the axis of symmetry. Now, to find the axis of symmetry, we can look at a graph and see where the this is a particular point called the vertex, which we'll be talking about more soon. The axis of symmetry always goes through that vertex, and it's the x value of the vertex, but how you find it is you take negative b and you're going to divide it by 2a. Now this says, does any part of that look familiar? And here we have our formula sheet, and you'll notice right here in our quadratic formula there's a negative b and 2a, so it's part of this quadratic formula that helps us find the x value of the vertex, which is the same as the axis of symmetry. Most times we can just get it from the graph. All right, so the very center point of the parabola. So when we have a parabola and it comes down and it turns around, the very center point where it turns around is called the vertex. It could also be called a turning point because that's where the graph changes direction. The x value of the vertex is the same as the x value for the axis of symmetry. That's what I was just saying before, because your axis of symmetry is a vertical line, so it's an x equals line, and so it's the same as your x value of your vertex. When the parabola opens up, the vertex is on the very bottom of the graph. So when our graph opens up like this, our a value is positive, but our vertex is down here on the very bottom, and it is called a minimum because it is the lowest point. Minimum. Okay. If our graph opens down, that's if your a value is negative. Remember, we just did that. Your vertex is up here on the very top, so it's called a maximum because it's the highest point. So it's just saying, is your vertex the highest point or the lowest point? and it depends on which direction your quadratic opens. Another thing I would like to remind you about is about domain and range. So we're going to take a second, we're going to place this equation into Canvas and do a quick sketch of it and then talk about the domain and range. All right, so I've placed the equation into Desmos, as you can see here. And here's our graph. You can always scroll in and out to help you see what's going on. Now, we want to find this very lowest point. That's that turnaround spot. That's the vertex, -4, -1. Okay, and see, here's our origin over here. So let's go sketch that. So we have our axes, and it pretty much looked kind of like that. And that point was -4, -1. Okay. We're not going to get too particular right now because we're focusing on our domain and range. All right, so now let's look at this. When it's not a real world graph, these graphs are really going forever. So I'm going to put some arrows on the ends of them. And so for the domain, remember, domain talks about left and right. The graph is never going to stop to the left because there's an arrow, and the graph is never going to stop to the right. So you remember that was something called all real numbers that we would use this symbol for. Okay. Now your range is up and down, and you're actually going to read from the bottom of the graph to the top of the graph. So you'll notice there's no graph below this point. That's the very lowest point on the graph, and everything's above it. So notice I'm talking about a y value here for this lowest point. So -1 is this y value, and every y value that's on this graph is going to be greater than -1, and it could be equal to -1. So greater than or equal to -1. So let's try it again for this other one. Pause the video and put your equation into Desmos and take a look at it. So here's our second equation. I can see I've got my axes. Here's my origin, and I'm noticing my graph is over here. Here is my vertex. You notice that's where it turns around at -4, +6. So I'm going to just do a quick sketch of that. And I must say this was -4, +6 was the name of that vertex. Okay, so for domain, this is a non-real world problem. It goes on forever and ever. It never stops left or right. So that's a real world, all real numbers. Your range is a y value. It's a up and down value, and you always read from the bottom to the top. Well, so here's the top. All of my y values are underneath this point, and that y value there is 6. So all of my y values are less than or equal to 6. All right, so we're going to try this with a few equations so we can get some practice on it, and you'll be ready to answer the activity questions. All right. Pause the video, put equation number 1 into Desmos. All right, so for what we're focusing on today, we're going to be looking mainly at domain and range. We're going to look at the vertex, the axis of symmetry, and max or min. So you really need to know your vertex, and everything else can be answered off of that. The most important parts of the graphs in general are your vertex, your x-intercepts, and your y-intercept, which we can't see here. We would have to keep scrolling. There's the y-intercept. It's up out of our range. All right, but what we're focusing on is we want to sketch this, and it has a vertex at -4, -1. That's where the graph turns around. So I'm going to sketch this. -4, -1. That's mainly what I'm concerned about right now. Okay, make sure you're making your parabolas U-shaped and not V-shaped. That's a different kind of graph. In non-real world problems, your domain goes on forever and ever, left and right. It's not going to stop. So we're going to call that all real numbers. Your range, this is the very lowest point. Remember, range is a y value. So we're talking about compared to -1, how is the rest of the graph? The whole graph is above it. So all your y values are greater than or equal to -1. Your vertex we just named, -4, -1. Our axis of symmetry. So our axis of symmetry Comes right down here through the middle of the vertex, and that's where we could fold this in half, and this half of the quadratic should match up with that half of the quadratic. So it is an x equals, so we would write x equals, and it's just that whatever the x value of the vertex is, that's the name of the axis of symmetry. And then the final one, is this a maximum or a minimum? Because this opens up, the vertex is the very lowest point, making it a minimum. Okay, let's go ahead and pause and try put this second equation into Desmos, and let's take a look at it. All right, so I put the equation in. Notice there's a negative sign here, and that's what's making us open down right here. Okay, this is a non-real world problem, meaning it's not a word problem, so our domain is going to be all real numbers. I've marked my vertex because that's going to help me answer a lot of these. For my range is y values. The entire graph is below this point, so all the y values are going to be less than or equal to 2. Your vertex we named, that's what we got from our sketch. Our axis of symmetry, remember, is this vertical line that goes right through the vertex, and it's a vertical line is named x equals the number where it goes through on the x-axis, but it will go through at 5. So x equals 5. This graph opens down, meaning the vertex is on top, making it a maximum. All right. Put the third equation into Desmos and do a quick sketch of it. Make sure you mark the vertex. Right, so I put the equation in, I did my sketch, I put my vertex on here because that's going to help me answer my questions. Our non-real world problems are going forever left to right, so that's our domain is all real numbers. Our range, the entire graph is above this lowest point, and range is y values, so all of my y values are greater than or equal to the y value of the vertex, which is -5. The vertex we've labeled -1, -5. Okay, our axis of symmetry, remember, it's the vertical line that goes straight through the vertex, and it goes through with the x value of the vertex, so it's x equals -1 is the name of that vertical line. And because our graph opens up, our vertex is on the very bottom, making it a minimum. Okay, let's try the next one. Pause the video, put your equation into Desmos, sketch the graph, be sure to label your vertex. Okay, so you're probably getting the hang. If it's not a word problem, our domain it's never ending left to right because of the arrows. Our range, the entire graph, is below that point. So we know we got a less than or equal to, and we're talking about y values. So you just look at the y value of the vertex. So it's less than or equal to 2. Our vertex we got from Desmos, -2, 2. Our axis of symmetry is this vertical line, and those are always labeled x equals, so you got to look at the x value of the vertex, which is -2. Because our graph opens down, the vertex is on the very, very top, so that makes this a maximum. Okay, let's look at number 5. Go ahead and put that into Desmos, make a quick sketch of it, and label your vertex. All right, so this one didn't actually shift off like some of the other ones. Okay, it was right here. Here's your origin, so it stayed on the y-axis. Your domain is all real numbers. Your range is a y value, and the whole graph is above, so that means greater than or equal to, is the y value of the vertex, which is -3. Our vertex we got from Desmos, 0, -3. Our axis of symmetry is the vertical line that cuts right through the x-axis, and so we always label that x equals, and what's the x value of your vertex, which is 0. And this graph opens up, meaning the vertex is on the bottom, so it is a minimum. What I would like you to do is pause the video and do the entire last problem on your own, see if you can answer all these questions, and then restart the video to check your answers.